Hello everyone, I apologize for this movement, but as I mentioned before, yesterday we talked about the color image processing, we talked about some color spaces such as RGB, CMY, and HSI. We talked about some equation that we can convert the RGB image to the HSI or HSI image to the RGB image. And now I'd like to show you an example about this because it is one of your final questions. Okay, and image is shown here. Okay. We have a patch of 3x3 image. Okay. As you remember, yesterday we mentioned that when we have the color image, in fact we have the three matrices R, G, and B. And each image has a specific value. For example, if you consider that the first pixel of the R, for example, is equal to 100, the first pixel of the G image or green image is equal to, for example, 200, and for the B we have the value of the 15, for example. And after combination of these image, we can generate a new color for our image. And if you want to show an example about the color image, each pixel has three values. For example, for the first one, 100, 100, and 100. It means that for the subimage of the red, the value of the image for the first pixel is equal to 100, also for the green, and also for the blue. The next one is 0, 0. You know, what does it mean when we have this value here? What's the color of this pixel? Red. It's red, but not pure red. It's some light red, because when we want to have the pure red, we have to write 255, 0 and 0. But it's in the spectrum of the red. Also for the next one we have 0, 50, 0. Means that the value of the red and value of the blue is equal to 0. It means that we don't have any red and blue color in this pixel. 255, 0, 0. Means that we have pure red here. Okay. 255, 255, and 255. If you remember, when we have the colors in the maximum values, the result color is the white, and 0, 0, 0. That's black. White, black, red, 100, 150, 200. Can you please answer? 0, 0, 255, 100, 200. 50. This is the value of the dispatch of the image. Now to compute HSI value of pixel 100, 150, and 200. Okay. Means we want to find the HSI values for just this pixel, but also with the equation you can find the HSI value for the other pixels. But for now we want to just find the HSI values of this pixel. Okay, as you remember yesterday I said that first we have to normalize the value of the red, green, and blue. How we can normalize it? With this equation. R plus.
Sorry, how we do this pixel in an image or not?
This is 100, 150, and 200. We want to find the value of this pixel, HSI values of this pixel. Okay, for green, you have to normalize it. G R plus G plus B, and for blue, B R plus G plus B. But for the first one, we have 100, 450. That's equal to 4.2 approximately. For the next one, 150, 450, it's equal to 0.333. For the last one, for the value of blue, we have 200 divided by 450. Okay? Means that we have the value of the 404. I don't mess up. Okay, first we normalize it. Okay, after normalization, as you remember, yesterday I said that to find the value of the h, first you have to find the value of the h, then s, and after that I. For the h, we have a condition for b less than g. We have to find the h by this equation. Cosine inverse (0.5) and after r minus g plus r g. Okay.
Can you read it again?
Cosine inverse,
Yes.
0.5 multiple r minus g, red minus green, plus red plus green. R minus g plus r minus b multiple g minus b over 2. Okay? When the value of the b is less than or equal to the value of the g, we have to use this equation to find the h. But for b less than g, we have to find it in this form. 2p minus cosine inverse, and again the same equation here. Just like this. But for the when the value of the blue is less than the green, we have this 2 pi minus cosine inverse and the rest. In our case, the value of the b, the value of the b is greater than g. It means that we have to use this equation. We can write it in this form. Minus cosine inverse (0.5) multiplied 0.222 minus 0.332 plus 0.222 plus 0. Write it. B, sorry. 4, 4, 4. Okay. And here 0.222 minus 0.333 over 2 plus r minus 0.222 minus 0.444 plus 0.333 minus 0.222 over 1 over 2, and there is a link to my calculation. I hope that will be okay. It's equal to 1. It's around 1.167 pi. Okay, that's around the 210 degree. We know that the value of the h is in degree. Okay, then if you wrote this, I want to okay, we find the value of the h. We can write it in this one. It's the value of the h for this pixel. And now we want to find the value of the S, or saturation. You know that that's equal to 1 minus 3 multiplied minimum of R, G, and B. Yesterday in the lecture, I had the two mistakes. The first one is for the equation of the S saturation. If you remember, we wrote it like this: 1 minus 3R plus B, R plus G plus B, minimum of R, G, B. That was one of my mistakes in the equation. I have to fix it. In the slide I will fix it, and I will again upload it on the module. But we have to find it in this form. Also for the conversion from the HSI to the RGB, also we had a mistake there. I will fix them, and also I will say that what's what's the correct equation. Okay, we can write 1 minus the minimum value of the RGB is the value of the R is equal to 0.2 that's is equal to 3, 3, 3. Then we know that the value of the S for the specific pixel is equal to this, and you know that for the intensity or I, we have to write it in this form. R plus J plus B over 3. In this form, we don't need that because you know that the intensity is say that the intensity actually is the gray scale of the color image. You don't need to use the normalized value. We have to write the exact value. It was the 100 plus 150 plus 200 or 3. But also, if you want, you can normalize it by you can find the value by this, but after that you have to again normalize it to the exact real exact value that we want. This is equal to 150. It's the value of the I, and we know that right now for the pixel values that was 150 and 200 in the RGB color space, we have these values: 210 degree, 0.333, and 150 value in the HSI color space. RGB. Okay. If you calculate the HSI in the MATLAB, you know that the MATLAB returns the value of the H in radian, but also all of you know that how we can change the radian to the degree. Okay. Here we convert the value of the RGB to HSI. It means that if we convert the value of the HSI to RGB, we have to get the same amount of these values for the RGB. We can test it. Okay, we want to convert the value of the pixel from HSI to RGB, and we know that we have to get these values for R, G, and B. As you remember, for convert of HSI from HSI color space to RGB. Excuse me, I closed the door. Sorry. Okay? Now we want to find the value in R, G, and B. And remember, yesterday we said that when the H value is between 120 degree to 240 degree, we have to use this equation for finding the H. H is equal to the value of the H minus 120 degree. Then after that we can use it. But also if you see the slides, you can see when the H is less than 120, we don't need to change the value of the H. And also if the H is between the 240 and 360, we have to minus it to 240 to find the new value. It means that for our case, it's 210 degree minus 100 degree is equal to 90 degree. For the value of the, it's 90 degree. Then we can calculate the R, G, and B value. You know that for the R value, we have to write this equation. I by minus S. Okay? We know that the value of the I, and also we know the value of the S. That the value of the S here is this. We can write 150 multiplied 1 minus 0.333. That is equal to 100. Because we estimate the value here, it means that with hyperbole we get, for example, the value of the 0, 0, for example, 1 or 2 or something like that. But we estimate it as 100. That's the value of the R. You can say that we have exactly the value here. For the value of the green, we have this equation I plus value of S cosine H cosine 63 minus H. Okay, we have to find the value of the G. With this equation, we can write it here. Okay, G equal to I 150 divided S 0. Excuse me, 1 plus 0.3 multiplied sinus of 90 degree. Okay, as you know that the cosine of the 90 degree is equal to 0. It doesn't matter what we have in the in this part. Then it's the whole is equal to 0. Then 1 plus 0 is equal to 1 multiplied 150 is equal to 150. That's the value of the green. You know we have it here and also R here. And for the value of the B, we wrote it in the slides yesterday like this: 1 minus R plus B. Was this rhyme? I will correct it, and again I will submit the slides again in the module. But the correct equation is this: 3i minus R plus B. Okay, we have the value of the R plus G. We have the value of the R, here we found it. And also the value of the G is equal to 150, and we can write it this. 450 minus 150, 100, 250, that's equal to 200. And you know that we
This equation, H equal or B equal, first of the equation.
this,
No.
this one, H equal to H minus 120 degree. This H is the exact value of that we have here. Because remember, we say that when the value of the H is between 120 and 240, we have to use this. But if the value of the H is less than 120 degree, we don't need to use this equation. And you know that easily we find the corresponding RGB value of the HSI, and also we easily found the HSI value from the RGB. And those some summation, and we can use this equation. Okay. Right now, you know, some question on the final exam, one is this, another is to calculate the value after applying some averaging filter or Laplacian filter. Okay. Well, like that. I want to show you a second. Okay. Let me to show some example on the MATLAB, and you easily know that how you can use some filters in the MATLAB, and how you can you will better understand that how you can smooth an image and or sharpen or use some sharpening filter. Okay. First, in MATLAB, open it. I think the font is enough big to see. Is it okay, or you need to increase the font size?
It's okay.
Well, just a second. I mean, okay, so do that. All of you know, with hyperactivity know that when we want to read an image in the MATLAB, we can use read comment MATLAB. For example, if you want to read a grayscale image, like tire.tip, some users are in the MATLAB dictionary, and no, I forgot to write semicolon here. Okay, I remember I mentioned before that for the grayscale image we have just the value, the size of the image means that we have the grayscales in the 2D, but for the color image, if we, for example, in red, butterfly dot JPEG, you can see here we have, for example, the size of this image is 2160 multiplied 3840 multiplied by 3. This 3 means that we have the color image, one that is red, green, and blue. If I want to show this to you, B. You can see we have a color image of butterflies. We want to see the R, G, and the B image of this color image. For this, we can write, for example, B red equal to B R value, R value, and first matrix is the, as you remember, I said that the first is the red matrix, B green equal to the second matrix is the green image, and the last one, the third matrix is blue matrix. Now, you can see when we wrote this matrices like this, means that we just have the image in the red, in the blue, or in the green and in the blue. You can see here blue with the size of the matrices like the 2 dimension. It means that we have we don't have any color image. We just have one monochrome image, not grayscale. If I want to show this to you, figure subplot 1 to 1. Okay. Show BR for the red. Sub one, 2, and show B green, and 3 B show B blue. Okay, then you can see that we have the image in just the red. It means that the R value of the blue matrix and green matrix is equal to 0. We just have the value in the red matrix. And also for the green, it means that the value of the red and blue are equal to 0. We just have some values in the green matrix, and the last one is the image in the blue matrix. So we call it blue image, it means that the red and green is equal to 0. And as you remember in this image, most values of the scalar is close to red, some orange and something. It means that in the red image it's more visible to us when we have the image in the red rather than the image in the blue. Also, you can convert the RGB. We know that this image or the color image by default is in RGB. We show it. If we want to convert it to the HSI value, we have to write this comment. For example, VB equal to RGB2. In the MATLAB we have HSV, hue saturation value, that's equal to with the HSI, but in the I and V we have changed, but we can use this because we know that the I is the gray scale of the image. Okay? B. Okay? We use the BV one time. Okay, it doesn't. But for the value of the B, you can see again we have a value of 3 here. It means that we have H, S, and in this color space we have V, but we can call it again I, intensity. And if I want to show this to you, okay. Show PV one for the hue. You can see here, and for the saturation, and also for intensity or value in the HSV color space 3.